evaluating rational expressions and finding restricted values of rational expressions. All right, the first thing we want to talk about is evaluating rational expressions, and then that's going to lead us to identifying restricted values of rational expressions. So if we're asked to evaluate a rational expression when x equals 6, to evaluate any expression, whether it's rational, polynomial, it doesn't matter. All we have to do is substitute the given value for the variable and then use the order of operations to simplify. So here we need to evaluate this expression when x is 6. So wherever we see an x, we substitute in the value 6. So we take out the x's and we put in 6's. And now we use our order of operations to simplify. 6 minus 3 in the denominator is 3, so we have 6 over 3. And 6 divided by 3 is 2. So the value of this rational expression when x is equal to 6 is 2. Let's evaluate this rational expression when x is equal to 2. So we replace all the x's with 2's. And then we'll simplify using the order of operations. Simplifying gives us 2 divided by 0. This is a problem because division by 0 is not allowed. And recall that dividing by 0 gives us an expression that is undefined. So if there's a 0 under the line, then that expression is undefined. So from this example, we can see that there are certain values for x that are not allowed. 2 is a restricted value because plugging in 2 for x gives us a 0 in the denominator of our fraction. We say that 2 is a restricted value of the variable. So let's look at this example. Here we're not asked to evaluate this rational expression. We're asked to identify all the values of x that make this rational expression undefined. So in other words, we're looking for restricted values of the variable. Remember, the restricted value is any value that makes the denominator 0. Well, it's easy to tell in this example that if I plug in 3 for x, my denominator will be 3 minus 3, which is 0. So that means in this case that x equals 3 is a restricted value. I sometimes call these disallowed values or DAVs. That just stands for disallowed value, which is the same thing as a restricted value. So in this example, 3 is a restricted value or a DAV, a disallowed value, because plugging in 3 for the variable makes our denominator 0. Here again, in this example, we're asked to identify all values of x that make this rational expression undefined. So in other words, we need to find the values for x that make the denominator 0. Well, in the last example, it was pretty easy to look at our expression in the denominator and say, well, 3 will make that denominator 0. But how about for this example? It's not so easy to look at this example and say, okay, what values for x will make this denominator 0? To find the restricted values of a rational expression, or to find the DAVs, as I call them, the disallowed values, all we have to do is take the denominator and set it equal to 0. And then solve this equation. And the solutions to this equation are going to be the x's that make the denominator 0. So this is a quadratic equation. Let's solve it by factoring. All of my terms are on the left side and 0 is on the right. So now let's factor the left side. The left side, x squared plus x minus 12, will factor into x plus 4 times x minus 3, and we still have equals 0. The left side is fully factored, so let's take each factor and set each factor equal to 0. So we'll have x plus 4 equals 0 and x minus 3 equals 0. Now solve each of those linear equations. Subtract 4 from the equation on the left to get x equals negative 4, and add 3 to the equation on the right to get x equals 3. And we found that x equals negative 4 and 3. These are our restricted values for this rational expression. These are our DAVs. Not 100% sure that we did this right. All we have to do to check is plug in -4 for x in the denominator, and then plug in 3 for x in the denominator, and both times our denominator will be equal to 0. One more example. Let's identify all the values of x that make this rational expression undefined. Well, the good news here is that our denominator is already in factored form. So let's just take our denominator and set it equal to 0. Now set each factor equal to 0 and solve. Let's solve the left equation by subtracting 7 from each side. That gives us x equals -7. Now let's solve the right equation. Take the first step by adding 1 to each side. That's going to give us 2x equals +1. Continuing to solve the right equation, let's divide both sides of that equation by 2. That gives us x equals 1/2. So again, in this example, we have 2 disallowed values, or 2 restricted values, x equals -7 and x equals 1/2.